Hi everyone, it's Miss Butler. I'm sorry I can't be there today. We're gonna watch a video and take some notes and make something called Mole Island. So for this video, you need the molar conversion video Cornell notes. You need your Mole Island paper. It should be either blue or tan, just kind of depends on what was available at the school. So it's a thicker sheet of paper. And then you need the molar conversion practice packet, this white packet. You'll need that throughout the video as well. In order to be successful, you will also need your periodic table and a calculator for this video. All right, this is where you're gonna be taking the majority of your notes. If I need you to switch papers, I will let you know, but otherwise everything should match up in order on this green note packet. There's page 2, and then there's the last page. All right, before we even get started, I want you to look at the white molar conversion practice packet, and then it says 1 step. You're not going to do every single problem on here, but let's circle the ones that we are going to do. So on the first page, you're going to do number 1A and number 1C. You're going to do 2B and 2D. And then on section 2, it starts with problem number 3. You're going to circle 3A, C, and E. All right, on the second page, number 4, you're gonna do 4B and 4D. And then we move into section 3, starting with number 5. You're gonna do problem A, C, and E. So A, C, and E. And then number 6, you're gonna circle 6B and 6D. And then section 4 just has problem number 7. You're gonna do 7A, C, and E. So circle those. You're not gonna do them right now, but when I tell you in the video to go work on the problems, you are just gonna do those problems that we circled. All right, for your warm-up, this is gonna happen in your green Cornell notes. I want you to find the molar mass of this aluminum carbonate. So Al, that's aluminum with a 2, and then in parentheses CO3 outside the parentheses 3. Find and add up the molar mass. You'll need your periodic table and calculator. Pause the video as you work, and when you're ready for the answer, you can hit play again. All right, so I'm gonna start with the aluminum. There are 2 aluminums in the formula because of this little 2, and I multiply it by the molar mass of aluminum from the periodic table. Then I look at this CO3. Remember, this 3 outside the parentheses applies to the carbon and it applies to the oxygen. So there's 3 of these carbons because of this 3 out here, so 3 times the mass of carbon. And then for the oxygen, 3 times 3 gives me 9. So we multiply those subscripts. 3 times 3 gives me 9 oxygens times the mass of oxygen. Once I get the red, the green, the blue, I add those pieces together and get my grand total for molar mass, or what this formula weighs, as 233.99, and that's gram per mole, G/mol. So like gram divided by mole is one way to think of it. All right, before we really jump in, I know you just did a calculation, but these calculations are gonna ramp up in intensity. What you need for this unit every single day is your tan periodic table, and you need a real calculator, not your cell phone. We're gonna be using some of the buttons on these calculators that are not available and do not work well on your cell phone. So you can have a calculator like this. This one here is a graphing calculator. It does more than we need it to, or you could have one like this. So whatever you use in math class is fine. Don't go buy a fancy calculator just for chemistry. But if you're using one like this already in math, then you can use that same calculator here in class. One like this, you can see on the screen, I looked this up over winter break, cost $10. And this I looked up on, I think, January 4th, and they could get it to me by the 6th, so only like a 2-day delivery if you have Amazon Prime. If not, I know Walmart sells them, Target, anywhere like that, but $9.99 feels like a good deal to get a calculator that has all the buttons you need for class. All right, so this topic is called molar conversions, and we have a goal of converting units to the mole. So 1 unit of measurement like grams or liters, and turning it into the unit called the mole. You've heard of moles before because we celebrated Mole Day, but I never actually really taught you what a mole is. So you finally now get to learn what a mole is. All right, a mole, okay, which we spell out fully as M-O-L-E if you want to abbreviate it. Unfortunately, the abbreviation is not much shorter. It's lowercase m-o-l. It's not just lowercase m. That would represent meter, so it has to be M-O-L for mole. But a mole is a unit that represents the number of particles in a substance. there's a specific relationship here that's highlighted. 1 mole of anything is equal to 6.02 times 10 to the 23rd particles of that substance. So if I have 1 mole of something, it means I have 6.02 times 10 to the 23rd. This number here is often called Avogadros number, the 6.02 times 10 to the 23rd, and that's named after this scientist who was called Amedeo Avogadro, so it's named after him. So 6.02 times 10 to the 23rd, that's a big number. Okay, I know it doesn't look big when it's written in scientific notation, but you can see, I know it's probably backwards for you because of the way my camera flips, but up on the wall here, this way, okay, you see that 602, and look at all of those zeros. They even wrap behind my head, around the corner there, all the way. So 602 has 23 zeros. So essentially what we're doing is we are moving this decimal place 23 positions and adding zeros as placeholders to the right in order to make a giant number. So it is a huge number of particles that represent 1 mole. So how does that relate to what we learned earlier this week about molar mass? Well, molar mass is how many grams there are in 1 mole of a substance, and we use the unit gram per mole, G/mol, saying how many grams in 1 mole. So think of it this way, mass is just how many grams there are. Right? Molar mass is a specific amount of grams that represent 1 mole. So, for example, if we want to find the molar mass of water, H2O, we take 2 times the mass of hydrogen and get 2.0, 1 times the mass of oxygen and get 16. We add those and we get 18 grams per moles. Here's what this means. If I have 18 grams of water, that is the same as 1 mole because it's the same as the molar mass. But that also means we have 6.02 times 10 to the 23rd particles. That giant number up on the wall behind me, right there, that big number with all those zeros, that's how many particles of water there are in 18 grams. So let's look. Here is 18 grams of water. Looks like not even enough to quench somebody's thirst. This is 1 mole of water because it weighs exactly 18 grams, the molar mass of water. But that also means in this little container right here, there are 6.02 times 10 to the 23rd water particles in there. What about sugar? Okay, I have 1 mole of sugar. This looks heavier, it feels heavier than 1 mole of water. Why does it feel heavier? Well, it has a bigger molar mass. We would have to add up 6 carbons, 12 hydrogens, and 6 oxygens to get the molar mass of sugar. But this weight of sugar is exactly 1 mole, which means we have exactly 6.02 times 10 to the 23rd molecules of sugar. Same with sodium chloride. This is about 58 grams of NaCl, just table salt. Okay, 58 grams is 1 mole for table salt, which means in this container I have exactly 6.02 times 10 to the 23rd particles of salt. We can do it for elements too, like aluminum. 1 mole of aluminum, if I look at Al in the periodic table, it has a molar mass of 26.98 grams. This is 26.98 grams of aluminum. How do I know? Because it says it's 1 mole of aluminum, so it has to be the molar mass. How many particles of aluminum are in here? Well, we know it should be, if it's exactly 1 mole, 6.02 times 10 to the 23rd particles. All right, in order to convert units to the mole, so to get moles of things so like I'm in grams or I'm in liters or I'm in some other unit, how do I get it into this new unit called the mole? We're going to use a process called dimensional analysis. Dimensional analysis is a fancy way of saying we are converting from one unit to another. Okay, we are going to use equalities to do this. So, for example, do we all agree that 12 eggs equals 1 dozen? If I have a dozen eggs, do we agree that that's like saying I have 12 eggs, they are exactly the same? That's called an equality statement right there, when we have 12 eggs equaling 1 dozen. So, if I ask you and I say, okay, I have 1,269 eggs. How many eggs do I have in dozens? Okay, most of you can probably do this just using your calculator real quick, but I'm going to show you a process, a format when we do dimensional analysis. So I always start with the number that's given in the question, 1,269 eggs. Okay, we are going to set up our bunk beds. In these bunk beds, we are going to always put the equality. the equal statement. One part of this equal sign goes on the top bunk, one goes on the bottom bunk. We want to cancel out the unit of eggs. So because I want to get rid of eggs, I'm going to put the 12 eggs part of the equality, this side on the bottom, and the unit I'm asking for, because I asked for dozen, how many dozen, goes on top, 1 dozen. So the equality goes on the bunk beds. When you were a little kid, what bunk did you always want to sleep on? We always wanted to sleep on the top bunk. We thought it was more fun. So the unit we want gets the top bunk. The unit we're getting rid of gets the bottom bunk. So I'm going to say that equals. So this is a multiplication. I am multiplying this number by this fraction. Here's a tip. In your calculator, if you multiply across the top, which this number here is considered the top, so I'm going to say 1,269 times 1, and that just gives me 1,269, and now my unit is eggs times dozen, right? Because we multiplied across the top. And then we're going to divide that answer by what's on bottom. So I divide that by 12 eggs, and what you'll see is when I take in my calculator 1,269 divided by 12, I get 105.75. And if you look at your units, eggs is on the top, eggs is on the bottom. The only unit we have left is dozen. So my units cancel out. So that's my final answer with the correct unit. What if I do this way? You've never seen this before, but 1 ATM, that's a unit for pressure, equals 760 mmHg. That's another unit for pressure. So we're probably going from one unit of gas pressure to another. If the pressure of a tire is 1.2 ATM, what is the pressure in mmHg? So we always start with what's given in the question, 1.2 ATM. We're going to set up our bunk beds. And remember, only this equal statement. I know these are foreign to you, but they can go in there. We want mmHg, that's our goal as our answer. So the unit we want gets the top bunk, just like the little kid wants the top bunk. 760 mmHg goes on top, so that's this side. And then 1 ATM is what's left, that goes on bottom. So in my calculator, I'm going to take 1.2 times 760, hit equal, and divide that by the number on the bottom, which is 1. So I get 912 mmHg as my answer. All right, so let's try dimensional analysis using molar mass and the mole. So do we all agree that 18 grams of H2O is equal to 1 mole of water? How do I know that? Well, remember earlier in these notes, we solved for the molar mass of H2O and said it was 18 grams per mole. Remember, that unit, gram per mole, means how many grams per 1 mole. So I can write this number like this, 18 grams equals 1 mole. That's the same as this. Okay, so now we're going to do the same process. If I have 24.3 grams of H2O, so that's the given number that I'm starting with, 24.3 grams, I'm going to multiply that by my bunk beds. How many moles of H2O do I have? So we want to know how many moles. Remember, we're only allowed to put this equality on the bunk beds. What unit do we want? We want mole. So I'm going to put the mole side, this guy right here, on top, 1 mole. And we want to get rid of grams, so I'm going to put this grams part on the bottom, 18.0 grams. In my calculator, I'm going to multiply 24.3 times 1, hit enter, and divide that by 18. When I do that, I get 1.35 moles, and I'll even put of H2O, so we know what the chemical is. That is my final answer. So we can use molar mass as the equality. Why don't you pause the video and try this one? So if I have 0.621 moles of H2O, how much H2O do I have in grams? Pause the video and give this one a try. All right, hopefully you pause the video. I start with what's given, 0.621 moles. We set up our bunk beds to multiply, and we want to get our answer in grams. Well, the unit we want this time is grams, so I'm going to put 18.0 grams on the top. The unit we're trying to get rid of is mole, so that goes on the bottom. Remember, you always want the top bunk, so whatever unit you're asking for, that gets the top bunk. These numbers always come from the equality. So now in my calculator, I'm going to take 0.621 times 18, and then hit enter, and then divide that answer by 1, and then I get a final answer of 11.178 grams, or we could say 11.18 grams. And that's of H2O. Put the chemical formula. Let's see, does this make sense? Well, we know from the equality that 1 mole weighs 18 grams. If you look, we started with less than 1 mole. 0.6 is less than 1, so I have less than 1 mole, which means I should get an answer less than 18 grams. Is my final answer less than 18 grams? Absolutely it is. It's 11 grams, so that's a good sign we did this right. All right. In the next page of your green note packet, you'll see that these steps are already typed out for you, but here's what we just saw with the water example. We found the molar mass, which we had done earlier. Water has a molar mass of 18. Then we write the equality that 18 grams of water equals 1 mole. Remember, not all chemicals will have that same equality. It's based off their molar mass, so you always have to find the molar mass. Then we're going to set up the equation, starting with what's given in the question, and then with our bunk beds. And so we have our blank bunk beds and we have an equal sign in our desired unit, so I just kind of leave room for my answer. Then we're going to insert the equality into the bunk bed so that the units will cancel. Remember, the unit we want goes on top bunk, the unit we're trying to get rid of goes on bottom. Okay, then we solve by multiplying across the top and then hit enter on our calculator, divide by what's on bottom, and box your final answer. Don't forget units. All right, you're not going to see these problems in your notes, but look, the slide says just watch, no writing. So I want to talk through this. We're going to go through those 6 steps. Here's the question. If I have 502 grams of CuSO4, how many moles of CuSO4 do I have? So step 1, find the molar mass of this chemical, CuSO4. So 502 is our starting number. It is not the molar mass. We need to use our periodic table to add up the copper, the sulfur, and all of the oxygen. So I take 1 times the mass of copper, 1 times the mass of sulfur, and there are 4 oxygens, so 4 times the mass of oxygen. These masses come from my periodic table. I add up those pieces and I get 159.6 gram/mole as the molar mass of CuSO4. So that is step 1. Step 2 is to write the equality. So if the unit for molar mass is gram per mole, we can split that up and say, well, 1 mole is equal to 159.6 grams. So the unit is gram per mole when it's in molar mass form, but if I write it as an equality, we put the grams on one side and the 1 mole on the other side. So now we're going to set up our equation. This is just the same problem, but they said we're starting with 502 grams. So I have my 502 grams. I have my bunk beds, and remember this is multiplication, so we're going to multiply by the bunk beds. And then I'm ready to write in my answer here where we get our desired unit, which is mole. So now all I'm doing, I already have my bunk beds ready. I want the unit to be mole, so we put the 1 mole from the equality on top. We put the 159.6 grams from the equality on the bottom. Okay, and now we're ready to multiply and divide to solve and get our final answer. So now I multiply 502 times 1, hit enter, and divide that by 159.6. My gram unit will cancel, and I'm left with 3.15 moles. There's my final answer. I double check that I have units, and I circle or box that answer. All right, I want you to picture right now that you are on the most warm beach tropical location. We got to get out of this cold Colorado January weather, so let's go somewhere warm. I'm going to take you on a trip. So if you notice in your notes, after those steps that were typed out for you, it says create your own mole island. So you are going to use your blue or your tan cardstock, whichever one you got, and we are going to make something called Mole Island. Welcome to Mole Island. You have arrived. Do me a favor, and on the back of your Mole Island, put your name and class period. In case it gets left behind, I can get it back to you. You are going to use it all semester. All right. You are going to grab some colored pencils or markers, whatever you want, and we are going to make Mole Island on here. Here's what you need to know. You will have Mole Island, the main island in the center, and kind of branching all around, you will end up with 4 other islands. So you have your, 5 total counting Mole Island, but Mole Island's your big one in the center. So around your big one in the center, you will end up with 4 more islands that you will need room for. But we're going to start with Mole Island in the middle. Okay, so we have our Mole Island, and then you're going to have Mass Island. That's what we just learned how to do. So Mass Island, and you can even put little g for grams to remind you that mass is measured in grams. All right, and we need to be able to go from Mole Island to Mass Island. So make sure it's obvious you have an arrow going from Mole to Mass Island. And here's what this means. So from mole island to mass island, make sure that's the direction of your arrow, we are going to put the molar mass in grams. So MM here stands for, if you want to make a note, MM is molar mass for whatever that chemical is. Molar mass in grams over 1 mole. So essentially what I'm saying here, if this is multiplication, there's my little dot for multiplication, whatever number is given when we have moles, we put that number in front and we multiply it by the molar mass over 1 mole, and that will get us to grams. We're going to go the other way. What do you think we do? Well, all we're going to do is flip that fraction. Let's take a look. So there it is. When we go from mass island to mole, what we're going to do is we are going to multiply that given grams. We are going to multiply it by 1 mole over the molar mass for that chemical. So just the key takeaway here is these bunk beds that you're writing on your mole island paper to help you are always going to get multiplied by the number given. And then you can make a note for yourself that MM, on this case, stands for molar mass. All right, here's a practice just to make sure you can just watch this one. If I have 2.54 grams of H2O, how many moles are there? So here's what I like to do. Here's where my mole island comes in handy. I see that they gave me grams, 2.54 grams, so that means I'm starting on mass island, and they're asking for how many moles. So I'm going from mass island to mole island. First thing I need to do in order to go from mass island to mole island is I need to find the molar mass of the chemical H2O. So I take 2 times 1.01 for the hydrogens, 1 times 16 for the oxygen, and I get 18.02 grams per mole. I can write that equality then, 18.02 grams is equal to 1 mole, or I can look at my mole island. My mole island says that if I'm going from mass island to mole island, what I'm going to do is I'm going to put the number that was given out in front and multiply it by 1 mole over MM, which is the molar mass in grams. So I'm going to say 1 mole on top, 18.02, the molar mass in grams on the bottom, and now we just solve the way we've been solving. Multiply this times 1, and then divide that by 18.02, I get 0.14 moles as my final answer. All right, at this time you have a choice. We labeled in section 1, 1A, C, and then 2, B, and D. All of these involve your mass to mole island. So you're either going from mass island to mole island using the molar mass, or from mole island to mass island using the molar mass. At this time, you can do these 4 problems that we circled right now, or you can, you would pause the video to do those and then just resume the video when you're done. Or what you can do is you can keep going with the video and do all the problems on this whole packet at the very end. Some of you might want to just get those out of the way because you know how to do them, they're fresh in your brain. Some of you like to do all the problems at the end, so that is your personal choice. All right, now that we've done our mass to mole and mole to mass, you can see on your green note packet, the next kind of gray box says create your own mole island to volume at STP island. So let's do that before we even get into taking notes. We're gonna draw another island, so volume, and the unit for volume is capital L for liter. And then I want you to also put at STP. I'll explain what that means, I promise. So we need to go from mole to volume, set up your bunk beds, and we will go the other way as well. All right, so when we go from mole island to volume at STP, for any gas at STP, which is standard temp and pressure, I'll talk about that when we get to the next slide, 1 mole of that gas is equal to 22.4 liters. So if I'm going from mole to volume, we are going to multiply that given number, whatever mole is given, we're gonna multiply it, there we go, there's my multiplication sign, by 22.4 liters over 1. So in this case, it doesn't matter what the molar mass is. If we're just going back and forth, we're always going to use the number 22.4. If I give you liters, we are going to multiply those given liters by the bunk beds that are 1 mole over 22.4. So that's how we go back and forth from volume island. All right, so back to your green notes, it says equality, so where it says volume liter to mole, the equality is right here. 1 mole is equal to 22.4 liters, and that has to be at standard temp and pressure, which is the same as STP, standard temp and pressure. And then there's a note for you what STP means. I want you to write down that the standard temperature is 273 Kelvin, and the standard pressure is 1 atm. So as long as we are at 273 Kelvin, Kelvin and 1 ATM, then 1 mole will always equal 22.4 liters. If we are not, I will teach you how to do that in a later unit. Okay, so here's a practice problem. If I have 6.1 moles of H2O, how many liters of H2O do I have at STP? So I know they're giving me mole here, so we're going from mole island, and then they want liters, so we're going to volume island. If we look at our mole to volume arrow, it says we take the given number, 6.1 mole, and my bunk beds should say 22.4 liters, because that's the unit we want. That gets the top bunk, and 1 mole on the bottom. So these numbers right here came from my mole island when I go from mole to volume. Okay, so in my calculator, I'm going to take 6.1 times 22.4, hit equal, and then divide that answer by 1. I get 136.64 liters as my final answer. Okay, I want you to try this one. Use your mole island. I have 30.6 liters. How many moles do I have? Pause the video and give it a try. All right, we put the 30, well, on this one, we're going from volume to mole. I put the given number, 30.6, in front of my bunk beds. And then to get from volume to mole island, we put 1 mole on top, 22.4 liters on the bottom. So I take 30.6 divided by 30.6 times 1, hit enter, and then divide that by 22.4, and I get 1.37 moles. Okay, notice on both of these, we did not need to find molar mass. That's the nice part. All right, same deal as before. You can now do section 2 of this worksheet. So that's number 3, A, C, and E. And number 4, B, and D. You can pause the video and do those now. They all relate with mole island to volume island or volume island to mole island. Once you're done with those, you can continue on with the video, or you can continue on with the video and do those problems at the end. All right, so in our notes, it now says create your own. So after we did the volume section, it now says create your own mole island to formula unit. So I want you to draw formula unit island for me and make a note. Formula unit can mean molecule, particle, or atom. So formula unit is kind of a generic term for particle, but you'll see the word molecule, atoms, or particle when we're discussing formula units. Now we finally get to use Avogadros number, the one we talked about in the beginning. So when we're going from mole island to formula unit island, make sure your arrow goes the correct way. We are going to put Avogadros number 6.02 times 10 to the power of 23, and I put FU for formula unit, over 1 mole. When we go the other way, what do you think we're going to do? Probably flip that fraction, and don't forget these are always getting multiplied by whatever number's given. You were right. When we go from FU island to mole island, we're going to put the 1 mole on top, and then the 6.02 times 10 to the 23rd formula units, or FUs, on the bottom. I am fine with you putting FU as the unit on your paper, but you better do it right if you're going to put FU to your teacher on the paper. All right, back to our notes. So we are on this section here. It's where it says formula unit definition. Okay, the formula unit is a particle, and that can be a molecule, a diatomic molecule, or an element. And we know that 1 mole of anything is equal to 6.02 times 10 to the 23rd formula units. So for this problem, if I have 0.632 moles of H2O, how many molecules? When I see the word molecule, that means they're asking me for formula unit. How many formula units do I have? So we always start with what's given. And because they're asking for molecule, which is the same as formula unit, that means we're going from mole island to FU island. If you look at your mole island, when we do that, it says we put 6.2 times 10 to the 23rd formula units on top and 1 mole on the bottom. Now, here's the tricky part. We got to put this in our calculator. What we're going to do is we are going to take 0.632, and I'm going to say times, and now I'm going to do my big number in scientific notation. That 6.02 times 10 to the 23rd is actually one number. Here's how I do it. I start by putting a parenthesis, and then I'm going to put 6.02. And now we need to do times 10, but we're going to do a button that's E. So what I do on my calculator is I'm going to do second. And if you look above my comma, you see that little blue EE? So second EE, and on my calculator it spits out a capital E, 6.02E. That E means times 10 to the, and then I'm going to put 23. Close the parenthesis. So right now, I know it looks backwards to you guys, but 6.02E23 is the same as 6.02 times 10 to the 23rd. I hit enter, and then I divide that answer by 1 because that's the bottom of my fraction, and my calculator says 3.80464E23. What that means, so in my calculator I'll round that first number, 3.8E23 is the same as 3.8 times 10 to the power of 23, and my unit is FU, or you can put the word molecule. All right, so before we do more problems, and you have room for these calculator tips, I recommend you use parentheses for each number. And remember, scientific notation is one number, even though it has that times 10. So 6.02 times 10 to the 23rd, or E23, that gets one set of parentheses. That will help so you don't have errors with your calculator. Okay, if you do the second button and then find where it's capital E, in your calculator, that shows up as 1E, and it means times 10 to the power of. So in your calculator, 2.0E24 is the same as 2.0 times 10 to the 24th, and I would put parentheses around that. All right, back to your notes. Let's try these. If I have 7.23 moles of copper, how many copper atoms do I have? So when I see atoms, I'm thinking formula unit. All right, so we're going to start with first we're saying from mole, because they gave me 7.23 mole, to FU. We always start with what's given, so 7.23 moles times my bunk beds. And if you look from mole to FU island, we're going to put 6.02 times 10 to the power of 23 FU on top, 1 mole on bottom. And now, in my calculator, I'm going to do 7.23 times, and I'm going to do parenthesis. So it looks like this, 7.23 times parenthesis 6.02 E23. So notice there's no there's no times 10 or carats in there, but in order to get that, I do 6.02 and then second EE, it shows up as 1E. Okay, for my calculator, that EE is on the parenthesis once I hit the blue second button. So then E23, I close the parenthesis and hit enter, and I divide that by 1, and I get my final answer of 4.35 E24 is what my calculator says. So I would write that as 4.35 times 10 to the power of 24, and my unit is FU, formula units. Okay, let's go this way. If I have 1.9 times 10 to the 25th molecules, so that's formula unit, how many moles do I have? So we're going now from FU to mole. So I'm going to have 1.9 times 10 to the 25th formula unit, or you could write the word molecule. If you look at your islands, we're going to put 1 mole on top, 6.02 times 10 to the 23rd FU gets on the bottom. So here's what I'm going to do. In my calculator, I'm going to do parenthesis 1.9 E25, so 1.9, parenthesis 1.9 second EE, so that's the E, and then 25, close the parenthesis, times 1, hit equals, and then I divide that answer, so divided by new parenthesis, 6.02, and then EE, or E is how it shows up in the calculator, so second EE, and then 23, close parentheses. And I get my answer as 31.56 moles. All right, we are almost done. You can pause the video here and do section 3, which is 5A, C, and E, and then 6, B, and D, or you can power through and do the problems at the end. All right, after you do those problems, or if you're saving them for the end, the last island is Total Atoms Island. Notice Total Atoms Island comes from FU Island, so there is no connection or direct flight from total atoms to mole. You actually have your arrows going from total atoms to formula unit island. All right, this island is pretty easy. If I have a molecule here, instead of just atoms like an element, if I have a molecule and I want to know how many total atoms they are, I'm going to multiply the number of molecules, or the formula unit, by the number of atoms in one molecule. So that means multiply. If we were to go the other way, we would divide, but honestly, I'm never going to ask you to go this direction on this pink arrow right here, but one year I left it off and kids were stressed that they would be stranded on this island, so I put it there. But really, we care about the green one, and it'll make more sense when I show you an example. So after you added that to your island, now we're back to the green note packet for the last time. And so here's kind of a typical thinking process. Here's the question. If I have 2.0 times 10 to the 24th molecules of H2O, remember molecule is the same as formula unit, how many total atoms do I have? Well, let's look. Here is one H2O molecule. In one molecule, how many atoms are there? 1, 2, 3. So 3 atoms in one molecule. So all we're going to do to go from FU island to total atoms island, which we're doing in this problem, is I'm going to take the given number of molecules, 2.0 times 10 to the 24th, and we're going to multiply it by how many atoms there are in the formula. How many atoms are there? Well, we said 1, 2, 3. So times that by 3. When I take 2.0 E24 in my calculator times 3, I get 6.0 E24. So it's 6 times 10 to the 24th, and I'll say total atoms. What about this one? If I have 3.1 times 10 to the 23rd formula units of sodium, how many atoms do I have, total atoms? So 3.1 times 10 to the 23rd molecules. Well, here's a sodium. In one molecule, there's just one atom, so we're just going to times that by 1. You don't even need to show that work. 3.1 times 10 to the 23rd total atoms. So in this case, they are the same, the total atoms and the formula unit, because one formula unit right here, one particle, only had one atom. So that's actually a pretty easy island to go back and forth. You just add up how many atoms are in the formula and multiply it by the number of molecules. All right, so now you should be able to do section 4, or really the entire worksheet. So it's number 7, A, C, and E. And then if you did them as you went, you're almost done. If you waited until the end, you have the rest of class to finish those circled problems. All right, here's kind of a finished up mole island. So far we have done mass. We've done mole, obviously, volume at STP, formula unit, and total atoms. We will deal with these later, and even if you didn't have room, don't worry about it. We kind of teach them in a different way. So your island will just have those ones that are circled. Good job, guys.